Welcome to this webinar. We are part of SogetiLabs, the group of thought leaders of Sogeti, and in this series of webinars, we like to talk about themes and topics that we find relevant and interesting and that are trend-setting, innovative, or new to us or our customers. So in this series of events, we have invited Albert to talk about recover, which is know to test, test to know, which is a very intriguing topic, is how you can reverse model things in relation to testing, which to me sounds sort of like magic. So he will show us some slides, have a conversation about that. The presentation part is probably going to take 40-45 minutes. We can have some discussion either afterwards or during. In the little chat window to the left of your screen, you can enter questions that we will then ask either at a relevant moment or at the end of the presentation. If there are any questions that we don't get to, we will answer them afterwards by email or in a separate follow-up. So without further ado, I would like to say welcome to our webinar, and let's get started.
Okay, so thank you for attending this presentation. Everybody can hear me? Yep.
Yep, all good.
Yep. Okay, so let's start. As Egg mentioned, the main aim of this presentation is trying to explain you the main highlights of this solution called Recover, which is developed here in Spain. We started 1 year ago, approximately. And the outline of the presentation is this one. First, we will try to explain you why we started working on Recover and which is the problem that we are trying to solve. After that, a little bit about what is Recover. If we have some time, a very small demo of Recover in action. And finally, we can discuss as you want about what I explained before. Okay, so let's start by talking to you why Recover, which is the motivation of this solution. Basically, the motivation or the background of Recover is that we have complex systems, growing systems, and these systems, either a road system, a software system, all of them are characterized by knowledge, very complex knowledge in many software. So we have basically concepts that define some valid states of the system, and we have also functions that also characterize the system, that is valid state changes in the system. The conclusion at the end is, okay, systems embody knowledge about the organization in which they are working, and therefore we need to manage the know-how of a system. We need to manage knowledge in some way. Also for software, because software is also a set of concepts related between them and many functions about its behavior. So managing knowledge is not something trivial, as explained in this sentence. Knowledge is like a treasure. So in order to learn and navigate through the knowledge of a system for the success of a project, we require something, and normally we require some kind of map, some kind of model, some kind of documentation with some quality properties like completeness, because we need to have this knowledge, accessibility, because we need to understand which are the main parts of this knowledge, and consistency between these parts. So we need something to learn and navigate through the knowledge of a system. And sometimes what we have seen in many organizations, in many customers, is that we have sometimes maybe the contrary, that is a lot of roles involved in a project, some professionals involved in a project, development people, testing people, maintenance, evolution, transformational projects, etc. And there is at the end only one system. And managing the different relationships, some of them positive like cooperation, others negative like conflicts, negotiation, managing all these relationships about that may condition the success of the project. Doing this, taking into account only the knowledge that is in the mind of each of the roles involved in the project is sometimes difficult, because we are based on expectations that are not explicit anywhere. So sometimes we require some requirements model or some documentation to be the base for addressing the problems derived from this kind of relationships in a project. It is even more important in the current context when, moreover, some of these profiles, some of these people can go out from the project. And if somebody goes out from the project and there is no explicit model or documentation about this knowledge, then we lose this knowledge. And this produces more problems for the project. The problem at the end may be summarized with this concept, the concept of knowledge depth. And it can be explained as follows. In the ideal world, we suppose that in each development phase of a project, we suppose that we think that we will use again what we learn in our moments, in our phase. We are working on the system, and we suppose that we acquire some knowledge and that we document this knowledge because, for example, in verification, in testing, or in maintenance, we will need to relearn this knowledge. But the reality, as explained in this typical draw, is that in many projects we have a lack of enough documentation or knowledge model specifications. So coming back to the initial example of the road system, if we try to navigate for our system without a map with enough quality, we need to relearn, we need to rework, and this rework, this relearn consumes time and resources, or in other words, it increases the knowledge depth, which have an economic impact, because what we know is that when we put the system into production, we need to come back to the system for maintenance, and we need to invest a lot of money for this maintenance. And this maintenance, for example, for corrective maintenance, is not only about fixing the thing in our programming language. It's more than this. It's also about knowledge management, about knowing what the system is doing right now and what the system should do. And this is why here at this point, reworking and relearning those knowledge that maybe was learned when moving forward in the development is so critical. So as any other depth, we only have two options. We can maintain and increment the depth, that is tolerating the risks of knowledge depth, or we can try to settle the depth for trying to work better. Which is the key point of recover, taking into account that managing knowledge of a system is like a treasure and is complex. The second part is that practicing, experience, and experimenting on the system is a key to get this knowledge. So what we observe is that testing is more than reporting defects. That when we are testing, we need to know what we are testing. So in other words, testers, as they perform their work, they are acquiring incrementally knowledge about the system, and therefore they become system experts. And if there is no enough documentation or there is no any knowledge model, then they need to experiment on the system. And in fact, already testing at this point implies recovering the functional knowledge of the system. So we are doing more than reporting defects. As we try to find out defects, we are learning about the system, so we are becoming system experts. The question at this point is why not providing more value from testing further than reporting defects? If we learn more, why not using this knowledge that we are acquiring as testers to specify such knowledge, to accumulate this knowledge, and to provide more value, because this knowledge will be useful for other roles involved in the project. So this is why we started working in Recover as a solution, with also an associated tool that helps us to provide a service that basically is based on these two key points. The first point is that, okay, as we test, we also recover the documentation about the functional knowledge of the system. Based on the tests that are executed on the system, okay, we are continue our testing project, we continue testing, we continue providing defects, but as we validate that the system allows to pass a test case, then this test case is used to obtain the documentation that corresponds to the real behavior of the system. And moreover, as we test, we are accumulating this knowledge, because this knowledge is the knowledge that is acquired also in the mind of each of the testers that participate in a project. So when we finish our testing service, in fact, we are providing not only defects, but also a specification of the system knowledge that we need to learn, because we are able to execute and design the test cases. So we are accumulating acquiring knowledge by experimentation, and we deliver also this knowledge as a deliverable of the project, more than only providing some defects. And another important point, documentation and specifications are only useful if they are maintained according to changes. Otherwise, documentation is not useful, because maybe 1 week after the delivery of the documentation, the system has changed, and then nobody would like to use the documentation for its purposes or the model. So as we test, we obtain the documentation, and as test cases evolve or the model evolves, then we maintain the alignment between the specifications and test cases, as we will see later. So what we try to do is offering a value-added service in which we incorporate the knowledge management in testing services. So testers, testing people, is not only someone who is finding defects. We say that by finding defects, we are accumulating experience, we are accumulating knowledge about the system, and we also deliver the specification of this knowledge. In a nutshell, what we say is, okay, we use testing, we use experimentation to recover knowledge that we need to acquire in order to test. But as we acquire more knowledge and we specify and validate it, we can use it to test better, and we can deliver it to other roles involved in the project, because at last, knowledge is at the center of what we do. Development people, testing people, QA people, maintenance people, transformation people, everybody needs to know about which is the knowledge of the system. So if it was not documented before, it was not specified before, we use testing. We use the testing project in order to generate another useful artifact that is about this knowledge. And then if we arrive to the maintenance phase, for example, or for transformational projects, then we are able to use this recovered knowledge for doing better our work, also for testing. But this is not an input-output solution. This is a solution like a wheel. First, we can start with no knowledge recovered, with an empty model, with empty documentation, and then as we are testing, we are acquiring knowledge, and then as we are acquiring this knowledge, we can be also users of this knowledge specification. So how we do this? Recover has an associated tool that helps us to provide this service. So this tool allows us to first specifying test cases by using an structured form. And then here we can define test cases as scenarios. Okay, these are scenarios, structured scenarios, as a set of steps, set of predefined types of steps. And we can define here our test cases, which in fact are test cases that can be executed manually or automatically on the system. So are real scenarios that are happening in the system. So here we have them specified, and then Recover has an engine that is able to simulate the execution of these test cases on the model, that is taking into account the knowledge that has been defined at that moment. So if we have a model that has all the knowledge that is required to simulate the execution of the test cases that we have introduced in Recover, then we could obtain a screen like this, in which we are sure that Recover is able to execute the test cases taking into account the knowledge defined in the model. At this point, we identify that we have an alignment between the test cases, that is the scenarios that are tested on the system, with the knowledge that we have defined in the model. So at this point, Recover allows us to click a button and then generate a navigable version of such kind of technical documentation, in which we can navigate for the concepts, we can navigate for the use cases, and we can see the representation of the functional knowledge of the system in several kinds of UML diagrams, as we will see later, and also some auto-generated textual description from this model for people who is not able to understand this kind of models. The first idea, therefore, is that, okay, we have a system, we have many different roles that work in the same system, and Sogeti, as a leader, for example, of testing, it is able to test the system, but it is also able to generate and evolve a documentation and a knowledge model based on the knowledge that is required for testing, the knowledge that is obtained by experimentation of the system. And the tool allows us to continuously check the alignment between these test cases, which are scenarios that are happening on the system, with the knowledge defined in the model. So we deliver some models and technical documentation that is not something that an engineer has written in a paper. Not only this is something that is derived from this, and this is validated because we ensure that all the knowledge required to execute the test cases that are like a proof of that the knowledge is valid. All of these test cases can be executed taking into account the knowledge that is included in the documentation that we deliver. And what happens if we detect an alignment between test cases and the knowledge model that we have at some moment. Well, at this point, we are happy because, as explained in this sentence, the first step towards knowledge is to know that we are ignorant. This means that, okay, in this screen, we are sure that for test cases, sessions, products, catalog, customers, administrators, we are sure that the documentation and the knowledge model that we deliver have all the knowledge to pass these test cases. But for example, here we have added another test case because we have another test case, a new test case for new functionality that deals, for example, with offers. And then Recover says, okay, you know about sessions, you know about stores, you know about manufacturers, but take into account that I am not able to execute the test case offers because in the knowledge model, there is not defined what is an offer and how an offer behaves. So then at this point, like in test-driven development, for example, here Recover suggests us how we should evolve the model in order to include the knowledge about offers. Once we include this, then we can apply the schema evolution and we can check again if now, at this moment, we have all the required knowledge for executing this new test case, but also checking that all the other scenarios continue passing. So we are including at each iteration of testing, we are including the required knowledge, the piece of knowledge that we need to include. And we are also checking that it has no lateral effects on the knowledge defined before. And if we add some test case that does not lead to new knowledge to be included in the knowledge model, then it means that this test case really is only enforcing the validation of the current behavior, but does not provide more coverage to the testing process. But the idea is that at each iteration of the testing process, we are also recovering the piece of knowledge that is required for simulating the execution of this test case. And Recover suggests us and applies automatic evolutions to the schema in order to include such knowledge. In other moments, we need to take a decision. If we have, for example, two test cases, and these test cases say absolutely, completely different things, then the execution cannot be passed for both the two test cases because there is only one model and there is only one engine that simulates the execution. So we will detect if we have two test cases that are contradictory. Basically, what we say is, okay, we continue providing the service of testing as we know it. We have a system under test, we have testers, these testers design test cases and report defects, but what we add is that we design test cases in Recover with this knowledge-based structured system, and then by using these test cases, we evolved a functional model, maybe empty at the beginning, and the engine that simulates the execution of these test cases in the functional model helps us to evolve the model in order to include all the knowledge required by test cases that at the end is a representation of the behavior about the system acquired by testers. And when we have a functional model that is aligned with the test cases in any moment, then we can click a button and then we obtain a deliverable documentation of the system. This is only to mention this, and we can get into details, but this can be applied, for example, also not only on traditional development methods, but also in agile methods, because in fact it is an iterative solution. So we are able to say, okay, we have a sprint, for example, in Scrum, and then if we test something in a Scrum, we are providing some working software, but not only working software. We also provide the piece of functional model and documentation that is required for developing this part of working software. This in a test last approach, that is, at each sprint we'll recover some functional model and documentation for maintenance, for transformational projects, or for other work on the system. And we could also adopt a test-first approach in which we start the definition of test cases before performing the sprint. So at this point, we define the test cases that should pass on the system. After this piece of working software is developed, we define them in Recover, then we obtain the documentation that will be also an input for supporting the sprint. Okay, so as we test, we are also recovering a knowledge specification that may be used then for more iterations in testing, for regression testing, and for maintenance, for evolutioning the system, for example. But evolution is a must. So the second important part is that we need to maintain this documentation. And as this is generated documentation from the model, the important point is that we are able to generate new versions of the documentation once the model has been changed according to changes in the test. So changing and maintaining documentation that is only textual documentation that has been written for someone is very, very, very difficult. So this is the reason why we have documentation that in a week ceases to be useful for people. At this point, as we generate it, if we maintain test cases and we ensure the alignment of these test cases with the knowledge model, then we can detect inconsistency, we detect evolution, and we can generate and deliver new versions of the documentation. Basically, what we say is that Recover allows us to know if we are in one of these two states. We may be in an alignment situation. In this alignment situation, test cases that we have in Recover are aligned with the knowledge model. That is, they can be executed on the model with no errors or failures. So we have in the model or the knowledge that is required for executing this test case. So at this point, it is very interesting to generate an updated version of the documentation. But what can happen as the project moves further? What can happen is that, okay, we are in a situation of alignment, and then, for example, business people said us that he wants to change something. If this happens, then we can use the model that we have recovered in order to use model-based testing, in the sense that, okay, we can change the model, and then we can use the Recover engine to check if some test case ceases to be passed according to the change that we are simulating on the model. So at this point, we can detect which test cases need to be refactored, need to be updated, because if we execute them on the system, we'll fail. And what can happen too? It can happen that business people does not communicate nothing to testers, and that we execute regression test case, and we realize on the system that something has changed. At this point, which is the right arrow, at this point, what will happen is that if we also change the test case in Recover, then we will check again the alignment, and probably we will find that we need to change something in the documentation, because it means that the system has been evolved. So solving the misalignment, applying the actions suggested by Recover, then we can modify the knowledge, we maintain it up to date, and we reach another situation of alignment, and then at this point we are able to generate an updated version of the documentation. So what we ensure is that really we are testing, we are moving further in the testing project, and we deliver documentation, technical documentation of the functional knowledge that is completely aligned with test cases. If something, if some change is realized, then we can easily maintain the documentation according to this change. So just to see a little bit how it works, let me introduce you a little bit this. Okay, here we have Recover. This is the tool. This is the tool that helps us to simulate the execution of test cases. We have here, as any other tools, we have a catalog of test cases and an editor of these test cases that helps us to define test cases as a set of predefined steps. Okay. We also have a tab about the model. Here we are maintaining the model, and we can try to simulate the execution of test cases taking into account the knowledge in the model. Here we have a model. We simulate the execution of our test cases, and at this point we can see that all the test cases that we have executed have the necessary knowledge defined in the model. At this point, we are able to generate the up-to-date HTML version of the technical documentation. We go to the documentation tab, and then here we can click this button, and then Recover takes the knowledge model that we have at this moment. We can download the generated documentation, or we can go to there. This is the kind of documentation that we generate. This is HTML in order to navigate for the documentation. We can navigate for concepts or for operations. For example, if we navigate for concepts, this is an example of an OS commerce software. And here, for example, if we want to know about what a customer is in our system, Recover generates a page with a focused diagram with all of the characteristics of a customer, how it's related to other customers in UML, and also which are the actions that the customer can perform with auto-generated descriptions for both the structural part and also for the operations. This is totally independent from the tool. It's only HTML, so it's a deliverable. For operations, we have a pseudocode that defines, totally independent from the technology, it defines how this action has an effect on the information-based state of the system. And we also generate textual descriptions for this operation for people who cannot understand this pseudocode. But basically, we can navigate. If we know about what a customer, we have to fix a customer in our system. We can go to see which are the characteristics of a customer. We can see that it's related to a shopping cart. And then if we want to navigate through the behavioral part, then we have an index of the use cases of the system, which are related to test cases. And then Recover computes which are the related concepts, which are the related operations, and also generate some sequence diagrams taking into account the test cases. These sequence diagrams are for scenarios that may happen, which act as examples of the documentation for people who want to know more, for example, about how the login process in this case is taken into account. And what happens, for example, when we introduce new test cases, as explained before? What happens is, for example, at this moment, we have a new functionality, and we test a new functionality of this e-commerce system about offers. Okay, we can introduce here some test cases, for example, to check that the net price of a product changes if an offer is enabled or disabled. Here you can see that this is a drag and drop editor for test cases. And then that right now we have that, okay, if we deliver this documentation, we don't have nothing about offers. So Recover suggests, okay, add the concept offer, and then you should add a not tribute offer price because it's used in the test cases, and a status, and you should also relate offers with products. And here this knowledge has been generated for the new test cases about offers. We can refine it, we can save it, and we can add it, this piece of knowledge, to all the knowledge that we had before in the system. As you can see, if we deal with all this knowledge in our head, is very difficult. So if we validate again the alignment, we can detect if we need to change something more. For example, here, Recover detects that the net price that was computed before as simply the price of the product, now it does not behave as expected because it has to take into account the offers. So if we follow the trend-driven evolution of the model, then we can check again the alignment, and now we are sure that with the evolution of the knowledge model, we have all the knowledge to pass the current test suite. So here we can generate a new version of the documentation that it can be generated, for example, in a repository, and then everybody that that wants to know what is an offer can go to the concept offer, can see the offer, and can see this knowledge. What happens, and this is the last part, what happens if we have the knowledge model and we change, for example, how a customer signs up in the system. We change some step, for example, of the model because somebody has told us that, okay, we have to change something about the sign map. Okay, then we can validate again the alignment, and we will realize that we have some test cases, and we will see which are these test cases that will need to be refactored if we really want to execute them. Because with the new knowledge, these test cases cannot be simulated without errors or fails. So at this point, that tedious task of refactoring test cases that we usually do it sequentially by checking the test cases that we designed before. Now, if we change the model because a change is communicated, then by click the validation button in Recover, we can go here and we can see if some test case is impacted. Okay, so you have this is a very little demonstration because we don't have too much time, but you have this URL where you can see a demo in YouTube. The conclusion at the end is that, okay, what we are doing is we provide a value-added service in which we provide more results than reporting defects. We also incorporate knowledge management, that is recovering, which is the knowledge that we acquire as testing the system. We have a tool that allows us to check the alignment, and when we have an alignment between the test cases and the knowledge model, it provides us actions to automatically evolve the system and therefore evolving to the documentation. This is about method because we could do it without the tool at the end, but it would be very difficult to take into account all the knowledge, checking this alignment without an automated tool. And it is also about people, because we need skilled professionals that know about the problems of documentation, the knowledge-based testing design. So they are able to structure test cases, they are able to use the tool, and then they are able to know how the tool works in order to recover and maintain this documentation. The value is for testing projects at the end because, okay, we obtain a resultant model of what we test, so it is an evidence of what we are testing, of the domain that we are testing. Sometimes it's very difficult to say what we are testing at this point. If we maintain the knowledge that we acquired in a model by using recover that facilitates other tasks, then we have an evidence of what we test. We provide added value because we are not some people that is checking that the system works. We become system experts that at the end we are this system expert, but we need to give evidence of that. We design test cases in alignment with a knowledge model, and this is very interesting because the assistant of Recover for writing test cases have auto-completion, so we can use always the same names for the same things, and we are also able to use the model that we are recovering, as we are recovering it, obviously not at the beginning when we don't have any model, but as we have more knowledge, we can simulate changes in the model to detect which test cases are impacted. But the value is also further than testing, because if we have a context in which we don't have a knowledge specification, and we write, for example, a maintenance or quality assurance of transformational projects, it's better to have some repository of knowledge in order to work better. So further than testing, we have some value of this documentation and this knowledge model, because, for example, someone who wants to fix the login process of a system, it will be more happy if it have a repository of knowledge where they can navigate and they can see which is what is a customer there, how is the current login process, how is the functionality now at the moment, and they need to be sure. They need to be sure that if something was detected that have been changed, then this repository of knowledge also changes, because otherwise it's not reliable for people, and otherwise nobody wants to use this repository of knowledge. An automated generation of documentation that is supported by the evolution of the experimentation on the real system, then we have more reliability of this documentation. This is the last part, only to conclude. So I remember the last discussion in SogetiLabs about testing services, and the last discussion was about how we can add value to testing services further than reporting defects. Maybe adding more results, maybe changing the way we explain what testing offers, maybe changing the name. What we say here is that, okay, testing services in the recover approach are not only about reporting defects, are basically an specialized experimentation on the system for managing knowledge and also for cross-wise quality assurance assistance, which, based on a model that is recovered, helps everybody of us, the people involved in a project, achieving the expected system with the expected knowledge, which is a common aim of all people that works on the same system. So this is about recover. I think that we have 15 minutes more, so maybe I'm on time.
Excellent, wonderful. So yes, we do have about 10 more minutes for people who have questions. There are a couple of questions. The first of it is very relevant, I think. Is this recover very Sogeti specific?
Well, recover is the tool developed by Sogeti.
So
okay.
Yes. So
and for the moment is only a supporting tool for a Sogeti service.
Yes. And where would Sogetians find more information about this?
Sorry?
Where would we find more information about the tool? Would we contact you directly, or do we find it somewhere?
Yeah, in Sogeti Spain website, there is a specific part for recover, but I can send you the flyer and I can send you more information. You have also this YouTube video just to reproduce a larger demo. Okay, but yeah, you can contact me or you can contact Sogeti Spain in order to know more about this tool.
Yes, good, good. So the best answer is let's contact Albert directly, and yes, the documentation will for sure at one point or probably already be in English.
Yeah,
Then
yeah.
Patrick Marquette from Toulouse had a question. Say, is it based on an ontology of the test? So what's your system based on? How does it work behind the scenes?
Yes. Behind the scenes, the engine is a little bit complex because it has a model, okay, and this model they have the structural part, then the test cases are structured, and then the engine tries to instantiate, okay, the states of the test case. For example, if you have a login process and you start with a customer, the system tries to instantiate a customer, specific customer as specified in the test case. If in the model there is no customer defined, then it says, well, here we have a problem, so I suggest you that you define the concept knowledge. If you use in your test cases that customers have a username and a password, and in your model there is no username or password as characteristics of a customer, then Recover is able to identify and it evolves the model in that sense. So it tries to simulate the execution on the model, which is something something that is not very evident at first sight, but at least it takes each test case and tries to use the knowledge to simulate that execution. And if, for example, there is an operation that computes something, if this operation is not well defined in the documentation, then it is impossible that Recover simulates it, and then it says, here we have a problem. Okay?
So Casper is asking plenty of questions. Casper, feel free to unmute yourself and ask your questions in voice. Does that answer the question? Does Recover replace existing test automation tools, or is it used in addition to these tools?
Yes, it's used in addition to these tools, because in fact it supports the recovering of the model. Okay, it is providing a way to efficiently create the model and documentation based on what you test, but you are continue testing manually or in an automated way. But further than this, there is another line of future features of Recover that tries to also connect Recover with automation tools, because if we have a model and we are recovering a model, then the model can be used to support the automation process. Okay, but for the moment it can be used in addition with the traditional testing process. What we add is that we use test cases in a more structured way, and as we use these test cases that are executed on the system, we use it to execute it on the model that we are creating as we move forward in the testing project.
Yep, excellent, excellent. So if there are any more questions, this is a good time to ask them. And otherwise, I would like to thank you all for attending here, for listening to this recording. Albert, thank you very much for this wonderful presentation and great tool that is sort of uncovered from the depths of Sogeti Spain. So I'm hoping that we can see more of this, because it looks very interesting and pretty brave to do a live demo on a webinar. So that's really combining all the risks that you can find, and it actually worked. So that's quite ambitious, and I like it. So thank you all for joining. The next in this series will be announced shortly. So again, please sign up and spread the word wherever you go, so that we can add a little bit to the fame and fortune of Recover and Albert, our SogetiLabs fellow from Spain. Thank you very much, and have a great day.